everyone. This is the second session of the Hawaii Adaptation Planning and Practices course. If you're just joining up, we were just talking story about what everyone's favorite food is. And so we're just gonna go ahead and move along. Oh, nice, everyone's still answering. Now I feel bad, I'm gonna wait a little bit. Also, Christian with the fresh lychee in his backyard. I would like that as well. Not in the cars up here where it's so cold though. Ooh, really koi mochi. Sounds good. All right. Anyway, we'll go on. Courtney, would you mind next slide? All right. So welcome back everyone to week 2 of the Adaptation Planning and Practices course. So just a reminder, before we really hop into everything, if you could keep yourself muted when you're not talking, and of course, if you have a question, feel free to unmute and ask it, or just type it into the chat box. Also, if your little Zoom name isn't your actual name, if you could just do that for us, it really helps as we get to know everyone on the project. And so, yeah, next slide, please, Courtney. Friendly reminder that lectures are recorded and all recordings will be posted to the NIACS YouTube page, where you can also find adaptation workbook online course materials. And if you or any of your team members have to miss one of the sessions, we do send out follow-up emails after each lecture with a link, so you don't really miss out on much. Next slide, please. So this is our team. The leads for this are Courtney and Maddie, but feel free to reach out to any of us if you have any questions or need any help with the workbook materials. And today's session, we've got session 2. So we're going to check in on step 1. We're going to do step 2 introductions, and it's going to be an overview of key concepts and really helpful resources that you can use for your projects. And we'll be wrapping up with a refresher on like what the assignment is going to be and the homework for next week. And after today's session, Dr. Ryan Longman will be doing some climate resource knowledge for everyone. And so step 1, we define location, project, and timeframes. And so for this one, we're going to be doing, well, really looking at 2 key questions, which are where you're working. I'm sorry, that was step 1. So it was where you're working and what are your management goals and objectives for this area. Next slide, please, Courtney. So this was, if you remember from the last session, the annotated picture that we did where we asked you to describe your project in 3 words and where your project is based out of. It looks like a lot of them are based out of Big Island, and so that's really cool. And overall, we're just really happy to have all of you be a part of this course.
Awesome. Thanks so much, Brianna, for kicking us off. I really appreciate it. And so before we dive into some of the content for step 2 this week, we just wanted to do another quick check-in on how you're all feeling about your goals and objectives. And so again, if you wouldn't mind using the annotate feature and just typing in your project name, it can be multiple people from your group or 1 person from your group if you're all working on a team for a project. So just type in your project name and then put a check mark. Do you think your goals and objectives still need some work? Are you feeling pretty good about them and ready to go? Or do you still think you need a little bit more time to tweak and mold them as we're starting to think about your project areas and really what you want to focus on for this course? So again, for the annotate feature, you can go up to that little more and click annotate, and then you can type in with the text, or you can add a stamp, and feel free to plop it onto the screen.
I have a quick question about the stuff we did for homework. This is Chris Balzotti with Nature Conservancy on the Big Island. I had proposed doing some coastal habitat work at one of our preserves, but when I was going through the homework section and I went to a lot of the resources, it doesn't seem it's even when you click what type of place you're working, it's all forest centric. Is that going to be a problem going forward, or is the adaptability in the adaptive climate workshop to handle that, or should I abandon that and do something different?
No, I think we should be able to still adapt as you need to really be able to focus on that coastal habitat for your project. So especially this week, you'll see a lot more of the resources are specific to Hawaii and the Pacific Islands with those climate change impacts and vulnerabilities. And there's always the option to add external resources and content like that into the tool. So that is all. It should be fine for you to be able to focus on that. We originally designed this for forest ecosystems in the Midwest and the Northeast. And so the tool still has some of that forest-centric language in it that we just haven't been able to update yet with our contractor who had designed this tool. But yes, please do focus on what is most valuable for you and what's the biggest priority for your project.
Okay, yeah, thanks.
Mm-hmm. No problem. Good question. Any other questions about your goals and objectives or your project or management topics at this point? Awesome. And it looks like people are thinking that their goals and objectives still need some work. And so do feel free to reach out to any of us that are working on any of the facilitators that Rihanna covered in that slide this morning, and we can all help you really start to think about some of your goals and objectives and how to really tweak those to best fit for the adaptation workbook process. But for someone who does think your goals and objectives still need some work, what are some of the big questions you still have about them?
One question I have is a lot of our topics relate to each other, and a lot of our goals are the same between topics because they relate to each other. And so we found ourselves writing the same goals but for multiple topics, and then the same objectives but for multiple goals. So any thoughts on that?
Yeah, I think it's fine if your goals cross some of those different management topics, because they're really going to, especially when they're those more broad goals of what you want to achieve in the future. And so I think the key thing to start distinguishing between are your management objectives then. So if you have a couple goals that cross your management topics, and then you have some of those key objectives that really help you narrow in on what is more specific and measurable for those different goals and those management topics. So especially if you're thinking of restoration as one of your management topics, then what are some of the objectives that you want to get to that restoration piece? Or if you're thinking about more of managing the invasive species, then what are the specific objectives for that? And then maybe you have one overarching goal that's really like maintaining natural diversity or something like that. And those two different objectives can fit underneath that. So I think that's how you can start to tease those little pieces apart. I don't know if that helped or not, Elliot. Cool. Any other questions or concerns about your goals and objectives? Cool. Well, this is helpful for us. So we'll continue to reach out to you over the next couple of weeks. And starting next week, what we really want to do is have some time to check in with you all and your teams one-on-one and have some of those conversations to answer some of these big questions that you might have as you're starting to get more familiar with the adaptation workbook tool. And so keep some of those big questions in mind, and feel free again to email us or type your questions in the chat as we're going along today. And we'll be sure that we can really help wherever you need it. And especially, you know, setting the foundation with your projects, with your goals and objectives is really important. So we want to make sure that those make the most sense and are ready to go as you're starting to work your way through the rest of the steps in the adaptation workbook process. And let's see, too many mouses and screens, but Awesome. Thanks, Maddie. So with that, Maddie, would you be willing to take a quick screenshot of this? Thanks. And thanks everyone for participating and again, giving us a sense of where you're at with step 1 and working through the adaptation workbook. The one other thing is I was looking through and I don't know if all of you have started a project in the tool yet, and if not, that's fine. But when you do, just make sure that it's associated with this course so that we can go through and make sure that you are getting the right tools and resources, especially because since we're focusing on Hawaii and the Pacific Islands, we don't want you to get a bunch of climate change impact statements for the Midwest or the Northeast or the Southwest. And so if you're associated with this course, hopefully you'll have the right tools to reference throughout the rest of the weeks that we meet. So again, that's just something to keep in mind when you're setting up your project in the online adaptation workbook tool. All right, I am going to clear the drawings and move on. So what we want to focus on this week is really step 2. So last week, as Rihanna said, we defined your area of interest, where you're working, and what your management goals and objectives and timeframes are. This week, we really want to start to assess those climate change impacts and vulnerabilities for the lands where you are working. And so we really want to start thinking about what are the specific local impacts of climate change to the areas where you work. And so one of the largest challenges that we deal with is really translating those broad regional climate change impacts and vulnerabilities and information into what this means for the specific climate change impacts to your project areas and the local ecosystems that we're working and managing. And so the first thing we're going to do in step 2 is really evaluate those climate projections, thinking about temperature and precipitation and shifts in species ranges, and combining all of that information with your expertise about the sites that you live and work and manage in. And what are the specific values that you're managing for? So if it's for recreation or pasture lands, or really thinking about wildlife habitat or aesthetics, whatever your management values may be, using your values and your expertise to really assess how your site is going to be affected by climate change. And so in this step, we're going to be answering 2 main questions to really assess those site-specific climate change impacts and vulnerabilities. And those are, how might your area be uniquely affected by climate change and those subsequent impacts? And how might regional impacts be different for your project area? And so again, with this step, we're really thinking about how do we take those regional climate change impacts and distill them down into how they're uniquely going to affect your area. So climate change is going to have a wide variety of effects across the landscape, and not all places and ecosystems or management topics are going to respond similarly. So for this reason, it's really critical to not only think about the general, so those regional or statewide impacts and the anticipated effects of a changing climate on ecosystems, but to also consider how specific places on the landscape are going to be affected by climate change. And so again, we really split this step up into 2 different components. One is an assessment of those regional impacts, where we're bringing in that literature and all the vulnerability assessments that have been done for the region and really compiling that all into a place that you can reference. And then thinking about those unique site-specific considerations about the areas you care about. And so when you go into the adaptation workbook and you mark your project location, it preloads your workbook with a number of regional impacts, including a list of impacts drawn from the latest national climate assessment. And so you should see a list of those in there. And so the trick is to really start thinking about how all of these regional impacts are going to play out in your specific project area, using your expertise and judgment for the areas that you work in. And so, for example, you might see a general regional impact statement for your project talking about an average increase in annual temperature in both the present day and with some of that future change with a low or high emissions scenario. And so in your project area, you might be concerned about things like the spread of invasive species or increasing wildfire severity. And so You might also have a site that's really prone to flooding already, or you've already seen damage from really heavy precipitation events. And so if you expect more heavy precipitation in your region in the future, that might be something that can be even more problematic for your project area where you're working into the future as well. And so really taking those regional impact information and distilling them down to the local level is what we want you to be thinking about in this step. So broad scale projections to that site specific impacts using your expertise about the areas where you work. And then this is just a written example and kind of what it could look like in the adaptation workbook itself. And so say you're working in an upland forest and you know that there's going to be more extreme precipitation events and some of those more intense tropical storms. So based on your knowledge of where you work, you might say that the slope and soil on the east side of your property is really vulnerable to that flooding or ponding. Or maybe you know that there's going to be the increased potential for extreme summer drought conditions. And you know that the hilltops where you work are especially vulnerable to growing season moisture stress. So those are some of those specific local impacts to your project areas that we want you to really be thinking about and distilling it down to that local level. And so with that, I am going to stop sharing my screen and Maddie's going to take over and talk about some of the resources that are available.
All right, thanks, Courtney. Can everyone see my screen? Okay, awesome. So yeah, I'm going to go over a few of the resources that might be helpful for step 2. And of course, after we're done presenting, we have Dr. Ryan Longman, who's going to go more in depth on climate impacts in Hawaii and share more regionally specific resources and data with you. So there's really a wide variety of resources available, and not all of them are going to be specific to your area. So we really want to encourage you to think about your goals and objectives and start to narrow in on climate change information that is specific and relevant to your project site. But before you go diving into learning about what those external impacts are going to be from climate change, we want you to first assemble the information about your specific project area that's going to be relevant. So this is a good time to start thinking about which of your own resources are going to be helpful for you to cross-reference with the climate change information that you'll be exploring. Oops, sorry. And I went way too far ahead. Okay, sorry about that. So yeah, moving into our resources. First, the Climate Impacts Explorer on the Adaptation Workbook website is a great place to start. So this includes a summary of climate impacts based on the most up-to-date science for each region you see here, as well as Alaska and Hawaii. So when you're working on step 2 within the adaptation workbook, like Courtney said, it's going to actually already automatically populate with these impacts. But you can also browse them here by accessing this link and accessing the Explorer. And so this is just a visual of what you'll see when you navigate to Hawaii and browse the impacts. So as you can see, it has the main impact statement in bold, and then a summary of the evidence beneath that, as well as linked citations for all of our sources. And then we had a lot of fun actually researching and putting together this sort of clearinghouse of Pacific Islands specific resources for our climate change response framework website. And so if you go to this link, you'll find a collection of comprehensive and topic-specific information, including sections on ecosystem vulnerability, vegetation, carbon, and biocultural stewardship. And, you know, we definitely don't want you to just limit yourself to the resources that NIACS has compiled. So there are tons of excellent resources available that may be more or less specific to your particular geography or management topic. So I'm just going to share a couple of those, but then we really encourage you, if you have another resource in mind that you think would be relevant, just reach out and send that to our team. So a great resource that's really nice for a quick overview of what main impacts to expect for your state are the NOAA state summaries. and they provide information on big climate trends and projections for all 50 states. And you can download a PDF summary of this or view the information online. And then, I know the links can be kind of tricky to get off of these slides. So just know that we'll also be sending out another one of those email newsletters after the course. So it'll have all that information in there and a copy of the presentation slides. And the fourth national climate assessment, which is what we base a lot of those impact viewer statements on, is definitely a must read. So I've found that this version is actually a lot more user-friendly than some of the previous versions. There's a lot of visuals and figures and pop-outs that dive into specific topics and just make it really easy to take in all of the most recent science. And last but not least, we have the Pacific Islands Climate Adaptation Science Center website. So they have a really wonderful project explorer on their site where you can dig into some regionally specific research and project descriptions related to a huge diversity of different impacts and management topics. So I was just browsing through that again just before this, and there are just tons of interesting projects ranging everything from projections about future coastal flooding and sea level rise to things like changes in water flow through Hawaiian forests due to invasive species and changing rainfall patterns. So there's a ton of good stuff, and this should be a really useful resource for everyone. And that's it on the resources until we hear from Ryan, but I just have one quick note about not skipping ahead in the adaptation workbook. So it can be really tempting when you're in step 2 and you're starting to look at all these climate impacts to start connecting the dots and thinking about how climate change is going to be affecting your management decisions. So when that starts happening, take note of those things. But for step 2, we really just want you to focus on the nitty-gritty of how climate change is going to be affecting ecosystem processes at your site. So think about the specific ways in which the hydrology, the soils, the vegetation and wildlife at your site are all going to be potentially vulnerable to different climate impacts. And then next week in step 3, that's when we'll start to explore how these impacts create challenges or even opportunities for your management activities. And I'll switch back to Courtney now. Thanks.
Thanks, Maddie. And so before Dr. Longman gives a presentation on, again, some of those regional impacts to think about for your projects, we also just wanted to walk through the next part of what you'll be doing in the adaptation workbook for step 2 as well. And so again, you'll be thinking about those regional impacts, compiling that information, thinking about how it specifically impacts your project areas. And then we also want you to give a vulnerability determination for your project. And so we really want you to think about how vulnerable is the ecosystem or management topic that you're focusing on to climate change. And so vulnerability is the degree to which a system is susceptible to and unable to cope with the adverse effects of climate change, including climate variability and those extremes. And so in other words, are climate change impacts really going to cause substantial disruption to a particular system? So that's the definition of vulnerability that we're using for the adaptation workbook. And so when it comes to vulnerability, there are 2 different components. Vulnerability takes into account both the potential climate impacts as well as the adaptive capacity of an ecosystem type. And so this graphic shown here is just to help you determine the vulnerability of your ecosystem or management topic, and it'll help us modify vulnerability. Or you might have a predefined vulnerability, and this will really help you modify what it should be for your management topic that you're focusing on. And so in the adaptation workbook, you can select various levels of impact from benefiting your system to disrupting your system. And you can also define your adaptive capacity of your system or management topic from low to high. And so to dive into this in just a little bit more detail, the potential impact of climate change can really be thought of as a combination of the exposure to changes, as well as the sensitivity of your system to those changes. And so again, what is your system exposed to? Those changes in temperature, increased precipitation, decreased precipitation, those high intensity storm events, changes in your dominant species, or a combination of a bunch of stressors, and then how sensitive is the system to those different changes. And so the big question that you're really trying to answer when you're thinking about impacts are the potential impacts likely to support or disrupt the health and function of your ecosystem? And so, for example, in Haleakala National Park, we could think about the region that the park is located within. We can think about the geology of the park and the varying elevation and topography, the microclimates that are created by that topographic diversity, and then the different soil types and plant communities and species. And then we can think about how sensitive the system is to those changes. So maybe one species in the park is going to be able to tolerate projected warming much better at lower elevations, but they might be more sensitive to warming at higher elevations and that higher extent of its range. And so that might lead to a potential shrinking in the range of that species. And so those are some different things to be considering when we're thinking about potential impacts. Another example that might resonate with you is if an area covering maybe the same elevation is exposed fully to 3 degrees of warming, you might see one species in that area that might be more sensitive to warming. So maybe the ohia might be more sensitive to those impacts. And then maybe there's a species that isn't as sensitive or might do a better job withstanding those impacts, such as koa trees. So those are different things to think about as well. And then we want to think about adaptive capacity of the system. So it's the system's inherent ability to tolerate those projected climate change impacts. And how well is the system going to be able to cope with those impacts? Or in other words, how resilient is the system to those potential impacts, assuming that there's no management intervention? And so this is different from sensitivity because we're really thinking about those qualities that might be able to withstand those impacts. So again, thinking about Haleakala National Park, we might consider areas at higher elevations that have some of those cold air pockets or really sensitive microclimates to have a lower adaptive capacity than maybe some of those areas in lower elevations. And so ideally, you would consider adaptive capacity of all of your dominant species within your system. But in another example, we might identify higher adaptive capacity, potentially in a forest containing a larger diversity of species, or maybe have a greater capacity to adapt to warming than just an ecosystem that has one primarily dominant species. And then another example for thinking about adaptive capacity, we could think about different species of Hawaiian honeycreeper. So the amakihi has a range from sea level all the way to 9,500 feet in elevation and has a really versatile diet that makes it less vulnerable to climate change impacts. And then on the other hand, the akikii is only inhabiting those highest elevations in Kauai. And so it has nowhere else to go with those rising temperatures. And so it has a smaller, it's more vulnerable and has a smaller adaptive capacity. So that's just another example to consider when we're thinking about impacts and adaptive capacity to determine vulnerability. And then examples of adaptive capacity factor in ecosystems can include characteristics related to your species diversity as well. So thinking about connectivity and the amount of fragmentation, or maybe there's not as much age class or a huge amount of age class diversity, and then the genetic diversity. So thinking about different bins can also help identify examples of adaptive capacity for your ecosystems. And then one other thing to consider as well is the adaptive capacity of hydrologic features. So think about characteristics such as if the system is maybe groundwater fed or if it relies primarily on precipitation. We can also think about the net flow into or out of a system. Maybe there's some soils that are able to absorb water better and hold it for a longer period of time, whereas some soils might be thin and over a bunch of bedrock and the water is more likely to run off. And maybe there's some impervious surfaces such as parking lots or other infrastructure that impact the flow of water to your site. Or maybe you're located at the headwaters or you're downstream. And so if there are detriments to being downstream, such as receiving agricultural runoff or seeds from invasive species, those are other things that might influence the adaptive capacity. So those are all different things to consider. And so again, when you're assessing vulnerability for your projects, you want to think about those direct and indirect effects of climate change, so those potential impacts, and then also consider the adaptive capacity, so the ability of your system to cope with those changes. And then you'll give an overall vulnerability rating for your project area. And then just another example, thinking about the Kauai mesic and wet forests, EcoAdapt has some awesome resources, and so does the Pacific Islands Climate Change Cooperative. And so I'd encourage you to check those out. And they've actually gone in and rated the vulnerability of some different management topics and ecosystem types. And so this one is pulled from their resources. And so they've thought about potential impacts to those mesic and wet forests. And those include things like increased drought risk, changes in precipitation and reduced soil moisture, increased frequency and strength of tropical storms and hurricanes, and then the increased potential of wildfire. And so when they're thinking about adaptive capacity, there's also some considerations such as the amount of habitat fragmentation, the invasive species that are already present and impacting mesic and wet forests, but there's also a high native species diversity in the area as well. And so the overall vulnerability was rated as moderate for those mesic and wet forests because those impacts are disruptive to the system, but there is some moderate adaptive capacity because of that high native species diversity. So that's just one example of thinking about the overall vulnerability rating for an ecosystem type or your management topics. And so when you get into the adaptation workbook, this is what you're going to see are these two sliding scales. And you can really rate the vulnerability of each of your ecosystem types or management topics on these sliding scales, thinking about, again, the potential impacts as being either supportive or disruptive to your system. And then the adaptive capacity, how resilient to climate change impacts or disturbance is your ecosystem or management topic from either low to high. And then finally, based on your ratings for potential impacts and adaptive capacity, you'll give a vulnerability determination. And so this can be, maybe you have a really high vulnerability, which means those potential climate change impacts are expected to exceed the ability of your ecosystem or your management topic to cope with those impacts. Maybe it's somewhere in the middle and it's moderate because the impacts are expected to alter your ecosystem, but your ecosystem is going to be able to cope with some of those impacts and has that higher adaptive capacity. Or maybe the vulnerability rating is low and your ecosystems are going to be able to readily cope with any of those potential climate change impacts that are projected for your area. And so with that, we just want to take a quick pause and see if there are any questions about any of the content about vulnerability or thinking about climate change impacts or some of the resources that Maddie presented on.
I've got a question. It seems like we have some big data gaps to be able to make those kinds of assessments. I'm just thinking for the example you gave of Ohia being less or more vulnerable than Koa, but Ohia actually has a greater range than Koa. So how did you make that statement?
Yeah, so there was one paper that I had found going through some of those resources, and I honestly can't remember who the authors were on it, so I can send it out to the group, and it was an older one, so the science may have changed, but it basically went through and thought about impacts and adaptive capacity at that species level, and really thinking about how some of those higher temperatures and changes in precipitation are really going to affect the specific sylvics of some of those species, and they gave an overall vulnerability rating. And so the vulnerability for Ohia was just higher than the one for Koa. So that was one example that I pulled. But I think there are a couple of those papers out there, and I think Ryan and Abby and Christian and Heather probably have a lot more ideas of where to find that. And so I'm hoping that that's something that Ryan is also going to be presenting on in his part of the presentation as well. But that is definitely a big part of this step, is pulling together those resources, figuring out where those gaps are, and then using your expertise of the species and the ecosystems you're working within to really determine maybe that's not true because ohia has that larger range. And so maybe they are doing better because they have more adaptive capacity based on the distribution.
Yeah, I think that it's just been something that's kind of a struggle on the species level. And then you also have this, the overlay of disease. I mean, for both of those species, you know, with koa wilt or rod, and even, I mean, I think that that's something that is needed and people are working on it, but like that drought tolerance of individual species and even across a range, you know, like our duohia, you know, that occur in dry areas are probably more drought tolerant, assuming. Anyways, thank you.
Yep, that's a great points and great questions. And so I think the other thing to keep in mind too is a lot of what we're doing through this course is really, we know that there's a bunch of uncertainty, but there are a bunch of tools and resources, and your expertise of the systems you're working within is crucial for really informing those conversations and thinking about what is going to be the most impactful to your system, and then how are we going to adapt to that, dealing with that uncertainty moving into the future. Andy, I saw your hand is up.
Yeah, you've been talking about the impact of climate change on the ecosystem, and we got to think of how the specific ecosystem is going to respond. I'm trying to change the ecosystem. I'm not so interested in how the current pasture land is responding, but those are the species that are there now. We want to make it a friendly place to restore the native ecosystem. You know, we want that's the management goal. So how is this assessment going to be working? Because my existing ecosystem is not the one I want. Am I assessing the vulnerability of that ecosystem or the one that I hope will be there in 30 years?
That's a great question. And so I think we really want to assess the vulnerability of your management goals and objectives. And so think about the one that's going to be there then in 30 years, because that's what you want to try to create. And so think about what are the current climate impacts to the current ecosystem and what that looks like in your area where you're working and managing, but then also think about what are those impacts going to be for the ecosystem that you want to create, and how is that going to inform what you want to decide to do on the ground. So as Maddie was saying earlier, we don't want to start thinking about how it's going to impact our management, but instead, how is it going to affect the ecosystem and the management topics that we're focusing on? So is there going to be an increase in invasive species? What is currently there? How is that going to change? Those sorts of things to kind of help inform the next steps in the process. Any other questions?
Courtney, this is Heather. I have a question. Yeah, Sierra brought up a good point. I just want to make sure it's being captured somewhere and that there are data gaps, right? So there's a lot of tools that you guys presented, which is great, but definitely there's still gaps. And so I don't know if there's a process for capturing what those are for all the managers on here, because our PyCask and myself, I would love to know what pieces are missing that would help everyone make their management decisions.
Yeah, that's a great point, Heather. And so we don't really have a formal place in the adaptation workbook to capture some of those data gaps. So we really are relying on all of you to let us know what those are, and we can keep track of those moving forward. So please either send us an email or type it in the chat box, or as you're going through this process and really thinking about how those regional impacts are going to play out at the local level, and there's questions you still have of what that's going to look like, those are the kinds of information that we still need to start to answer these questions better moving forward into the future. And Heather, did you have a way that you were hoping to compile that information?
Well, right now I'm just taking my own notes, but I just wanted to either propose or really just find out if there's a more formal way. So, you know, that would influence how I'm taking my notes and listening a bit. But yeah, no, that was my only question. So I will continue to do that and be glad to share what I have. All I've heard, you know, today is that there are data gaps, but what those are, I don't know yet. So maybe we can, maybe if there's a place in any of this throughout this course, we can focus on that for near the end. If after everybody's done their whole course and they realize there's some bits and pieces missing to put the puzzle together, we can highlight what those are.
Thanks, Heather. Yeah, that would be great. And next week, we will come together and we're going to have a discussion about some of the impacts that you're thinking about for your projects. And so that might be a good place too, as you're starting to think about this and as you're doing some of this research and pulling together the different tools that are out there, and you're finding some of those additional data gaps, that might be a good place to have some of that discussion next week as well.
Yeah, and on that topic, I think it's worth mentioning too that step 5 of the adaptation workbook is monitoring. And so, you know, groups will decide kind of how far to go with that, but we definitely have had other projects where monitoring was actually kind of like the most robust part of their project. So, you know, if it's like a certain data gap that you have in mind or something that you think is really relevant for a site, definitely bring those ideas to that step 5.
Great point. Thanks, Maddie. Chris, I see your hand is up.
Yeah, I mean, I can give you one of the really big gaps that I think a lot of us struggle with as far as drought adaptability, and that's the flow of water. Beings that, you know, we're sitting on pretty porous substrate. A lot of our water goes underground pretty quick, but how deep it goes and where it moves. Kim Falinsky, I know she did her PhD work on that, and she's now with Nature Conservancy. So I'll reach out to her to see what her updated maps are. But I know I've really struggled over the years to find really meaningful data about the flow of water and what's actually available to the existing forests. We know they capture the water. We know where it comes out at the ocean, but we don't know very much more than that. There's some local areas that we know, but my guess is most people on this call are sitting on landscapes where it's just not really known how much of the water is actually staying in their system and how much is going so deep so fast that it doesn't get access. So that'd be a really cool resource if someone knew, anyone else, that it was working in that.
Awesome. Thanks, Chris. Does anyone have any additional resources or information we could share?
So in terms of Chris's question, what you're talking about is water balance, and you know the USGS has done some water balance stuff on Maui. They haven't done for the whole island as far as I know, but I think that there's a lot of efforts moving towards that. There's some products coming out in terms of real-time um, gridded products that are going to be able to address these questions. They're just not available now. I mean, there is some information out there, but I think we're moving in a direction where we're going to start having these products because there is a demand for them, and I mean on a really a gridded basis. So everywhere in the state, but it's just we're in the early stages of that, or the folks that are doing are in the early stages.
Thanks, Ryan. Awesome. Any other questions or data gaps that you're thinking about right now that you'd like to share with the larger group? Awesome. Great discussion, everyone. I really appreciate these questions and this feedback, and it'll really help us over the next several weeks as we continue with this course to really try to compile some of that information and again, get your input on what information is still needed, where those data gaps are, and how we can really use that to start thinking about climate adaptation actions. So I really appreciate the additional input and feedback. So in a minute, we're going to pass it off to Dr. Ryan Longman, and he's going to talk about some of those impacts and resources as well. Really quickly, though, before we do that, because I want to make sure Ryan has enough time to answer any questions you have at the end. Some additional things to think about this week in the adaptation workbook for step 2. You'll see a list of those pre-populated statements about impacts of climate change that are specific, again, to Hawaii and the Pacific Islands. And so this was filtered when you dropped your pin on the map. So what you'll want to do is go in and remove some of those regional impacts that don't apply to your project. And so you can just use the little X to get rid of the ones that aren't specific for where you're working. You also are going to want to get specific and describe how climate impacts will affect your project area. And so you can add your own custom impact. You can pull citations from some of the references we talked about, additional information you're pulling from the National Climate Assessment or PICASC, or some of the information Ryan's going to present, and really start to think about those local impacts that are most valuable and important to you. And then for next time, again, between now and next week, we want to be looking at those impacts and vulnerability resources for your project and areas. There's some great information, as Maddie pointed out, that's been culminated onto that forestadaptation.org page for Hawaii and the Pacific Islands. There's also some helpful video presentations that focus on forests. If you're not focusing on forests, that might not be as helpful of a video to watch, but if you are, something to consider. And then again, complete the step 2 in the adaptation workbook by starting to assess those impacts and rating your vulnerability, and then doing the short little homework after step 2. And so next week, we're going to meet again on Tuesday, February 9th, and we'll come together and start with that discussion on those climate change impacts and vulnerabilities you're thinking about for your local project areas. And then we're going to move into starting to evaluate those management challenges and opportunities. And then again, it'll be great, especially as some of these questions are coming up, please make sure you're checking in with the facilitators, and we'll talk about all of that more next week. So with that, I am going to stop sharing my screen and pass it off to Ryan.
Okay, thank you very much. Let me just share my screen now. Okay, you should see a snowy landscape, and now okay, do we see a presentation?
Looks good.
All right, thank you very much. Awesome job, Courtney and Maddie. Appreciate the introduction and the good work so far. Today, we're going to talk about I kind of had a creative liberties on this presentation, so it's kind of a hodgepodge of a few different things, but I think we're going to learn something, and I'm happy to be here and sharing this. Courtney, is an ideal time 20-30 minutes? What's the ideal time to go about?
You have 40 minutes until we call it at 10:30.
Okay.
So, yep.
Sounds good. Okay, so for today, I'm going to start off talking a little bit about climate patterns and basics. I've taught Geography 101 for a decade at UH, so I can't get it out of my system to not teach some folks something about how the climate operates here in Hawaii. That would probably be even more interesting for the folks that are on the mainland right now, but happy to share that. I'll talk about some of the observed changes, some of the ways we've seen the climate change over the past 100 years or so, and then talk about some future changes, some of the modeling work that's been done in Hawaii, and impacts in Hawaii. And Maddie did a good job of showing you where some of those resources are, but I'll kind of briefly go over that because there are a lot of different impacts that are going to affect everybody a little differently. And then finally, we'll talk about data and information. And again, Addie showed you some great sites for where you can go and get great information. I'm going to talk a little bit more on the data side. I'm kind of a data guy, so I'm going to show you where you can get the data you need to support your projects. Okay, so what factors affect the climate of Hawaii? We know that we live in this really diverse place with incredible microclimates that change over relatively short distances. We get these crazy gradients that go on, and we're situated in the tropics, so we have this steady stream of insulation that gives us these moderate temperatures. We're surrounded by oceans that also moderates the temperatures, but we have these really dynamic systems that interact with the topography, which is ranges up to 14,000 feet, and we have these really interesting ecosystems at high elevations that are really dry. So we'll talk a little bit about the factors that affect that diversity. And really, we have these factors that affect horizontal differences, so the leeward and windward aspects that we're all familiar with. And we also have vertical differences in climate, and predominantly caused by temperature, but also because of this feature in the atmosphere called the trade wind inversion. So I'm going to talk a little bit about the global mechanism that creates this diversity. And it starts with looking at large scale atmospheric circulation. So at the equator, temperature is warm, air rises, gets to a point where the air condenses and you form a clouds. And we have this band of clouds that kind of wraps around the globe. We call this the intertropical convergence zone. But eventually the air gets pushed poleward, and then it descends back down between 20 and 30 degrees. And then at this point, it returns back to the equator via surface winds. We know these as our trade winds. And this is a circulation effect, and we call this Hadley cell circulation. This is really important to understand when we're looking at things like winds and the trade wind inversion here in Hawaii. And the thing you have to remember is low pressure, where air is rising, and high pressure, where air is descending. So if we look at our little schematic here, we have this semi-permanent high pressure cell that sits to the northeast of the Hawaiian Islands, and it drives winds from high pressure to low pressure, the surface winds that I showed you up here, and they're deflected to the right in the northern hemisphere. So these are essentially our trade winds, and they're there between, they're more prevalent in the summertime, but between 50 and 90% of the time in the year you can have trade winds. So we have one side that's exposed to the wind and another side that's kind of behind the mountain. That's our windward leeward effect. So this particular latitude where we have this high pressure zone is associated with really dry areas. So we have there's area over here that's about, I don't have in this box, but that has to do with the monsoon. I'm not going to explain that. But this area, this band of latitude, is really a dry area. We look at some of these areas we see here, and the Hawaii is kind of in this band of high pressure, and it should be a dry area just because of the way the atmospheric circulation works. But we know that it's not. We have a lot of rainfall here. And this is really a result of the topography of the islands and the orographic lifting that takes place. So the simple model is that the sun warms the ocean, we get evaporation, and as a result, we get this really moist air that surrounds our islands. Trade winds come into play, and they push that moist air up the mountain. Okay, and we call this orographic lifting. As the air moves up the mountain, it gets cooler, and it's not able to hold the moisture anymore. The moisture condenses into a cloud, and we call this an orographic cloud. And the point at which that cloud forms is called the lifting condensation level, or the LCL. I'm going to remember that for later, because that is going to change with climate change. And this area above the lifting condensation is known as the fog zone, and that's where we have our tropical montane forests and all the species that exist in that moisture-rich area. And we get this steady stream of rainfall called this orographic rain. And for islands like Oahu and Kauai, we get that rain can come over the top of the mountains. Now, as that air moves over the mountains, because of that release of energy, when it condensed, it's a little bit warmer and it's drier now. So on the leeward sides of the islands, we have this hot, warmer and drier air descending down. So that's why it's a little bit warmer on the leeward side, because of that release of energy and that really dry, warm air that moves over the mountains. Okay, and so the wettest areas on Oahu and Kauai, the lower mountains, are the top of the mountain in this fog zone. And then for the taller islands, we have this other feature called the inversion, which I'll explain in a second. Now, for the leeward areas, a lot of the leeward areas get their rainfall from storms. So low pressure systems that move into the islands, and they're not super frequent, but it's enough to bring significant amounts of rainfall over the year. So one type of disturbance, we call it a disturbance because it disturbs the normal conditions of this high pressure, is a cold front, and that's just basically cold air moving into the islands. It displaces the high pressure cell, and it brings air from the south. So that's where we get these Kona winds or the southern wind component. And we also have usually a very stillness before the cold air comes in. And then after the cold air comes in, we also have a stillness. This is the calm before and the calm after the storm, right? So again, the high pressure cell is displaced. We also have low pressure systems that come in, and again, they're called disturbances because they disturb the normal conditions. So a low pressure system moving from west to east in the westerlies. This also brings winds from the south. And then sometimes these pressure systems break away from that westerly flow. They can move anywhere around the islands. And you guys know these as Kona storms or Kona low pressure systems. And as long as they're situated near or to the north of the island, you'll get a southerly wind component as well. And these storms are really critical for leeward areas to receive rainfall. And then we have tropical systems. They're rare. Between 2 and 4 years, we get significant rainfall from a tropical system. We've had some in recent years for sure with Hurricane Lane, 2018. So and then we get low pressure troughs that come through. So these are all ways we can get rainfall to the leeward sides of the islands. Now, in terms of the vertical changes in climate, this is the example of the trade wind inversion here. We have what we call a trade wind inversion, and everybody that's been up top of Haleakala or Honolulu or has flown from one island to another has seen this. And I hope you might not be able to explain the mechanism behind this, but it ties right back into this atmospheric circulation we have here. So the way it works is that when you're at a low elevations, go up in elevation, temperature decreases. Okay, that makes sense. Everybody's gone up a mountain, it's gotten colder. So the same thing happens when you go from high elevations to low elevations, temperature gets warmer. But because the air at high elevations in Hawaii originated from the equator, it's just the slightest bit warmer. So it cools at the same rate that it warms, except that because the air starts a little bit warmer, we get this point when the air meets up that is a discontinuity where it slightly gets warmer. And this is what is called the trade wind inversion, okay? And because the air slightly gets warmer, it limits the ability for clouds to develop vertically. So clouds will rise as the air above them is cool, but once it gets to some warmer air, it won't rise anymore. And this creates this really dry, stable air at these high elevations. And this is a look at the meadow on the north shore of Maui and a look at the inversion. And I know everyone's familiar with that, but hopefully the science adds some context to that. And then here's a schematic of Maui, and we expect this on the Big Island as well, but just to kind of tie things together, trade winds, and you get your orographic cloud, orographic lifting. On the leeward sides, we have a slope breeze, that's a land ocean breeze, or on the Big Island is a return flow trade winds. And so we get cloudy conditions there, but not so much rainfall. Except in the summertime on the Big Island, we get significant rainfall from that. And then in the absence of the inversion, we can have clouds go all the way up to the top of the mountains. But when the inversion is present, the cloud vertical development is stopped, and we have these, again, dry, stable conditions at the highest elevations. And then here's a look at Haleakala without the inversion here below, and then with the inversion above. So it creates considerably different conditions. And this is the actual profile here, air temperature with data. And so it's not completely uniform, but you can see the inversion is captured there as well. So you can find that with the atmospheric soundings that they have in Hawaii, Hilo, Hui. Okay, so that explains vertical and horizontal differences. Hopefully that was a quick and easy geography 101 lesson for everybody. But what we get here as a result of those is these really unique climate patterns that, again, change considerably over very short distances. So for temperature, we can go from 75 degrees Fahrenheit to 40 degrees Fahrenheit, just from going, up the mountains. And we also have very unique rainfall patterns where we have, again, our windward sides are going to be wet, our leeward sides are going to be dry, and it's really going to be significant. So less than 10 inches of rainfall, 25 inches, as opposed to 250 inches in the Koala Mountains. You see a couple more, areas here, and then the wettest place in the Hawaiian Islands was determined. They updated the rainfall atlas, was a Big Bog in Hawaii, which is 400 inches per year. And we have a climate station there as part of a network, so we can confirm that, although it's really hard to get to. And this is some work that is by Abby Fraser and Tom Giambaluca. They put together the Rainfall Atlas of Hawaii. So this is a great resource you can go to and explore the areas that you're interested in and look at climate, rainfall over the course of the year, and find the rainfall or during any given month. And you really can hone in on your particular area to get that information. We also have other climate information I'll show at the end of the lecture too, where you can really look at all these other variables too. And what's really cool about this is the interactive maps. Another thing I'm not going to get too far into, but it's really important to understand is that there's natural variability that goes on in Hawaii. So we're not talking about an anthropogenic change signal. We're talking about these changes that happen naturally in the Earth system. And one of them we know that affects Hawaii and particularly is the El Nino Southern Oscillation, or ENSO. And you can see that looking at these indexes here that, sometimes you move the positive phase of El Nino to the negative phase of La Nina, and that changes every 7 years. And then there's another mode called the Pacific Decadal Oscillation. It operates on a little bit longer time scale. But again, we know that these things affect climate Hawaii, particularly rainfall and temperature. So it's important to understand these, because it's important to understand what these modes will mean to your area when they're in either the positive or negative phase. There's certain conditions that we can expect. And the El Nino and La Nina operate basically because of a change in temperature in the Central Pacific. So during the El Nino, the winds are weaker and the water is warmer, and that changes things like even the orographic lifting in Hawaii, and it changes the temperatures in Hawaii. Temperatures are warmer, winds are less, yet less rainfall in the wintertime. And then La Nina, the wind is moving faster, it's cooler, the ocean, so you get cooler temperatures, and you get typically more rainfall average. But these are complex processes as well, just giving a real general idea. But this is what it looks like for a strong El Nino event in Hawaii. Look here, December, January, February, March, April, May, you see really dry conditions. What's unique about this is that during the summertime or during the dry season, we see actually an opposite effect. During a strong El Nino, we actually see some wetter conditions. And I've done a ton of analysis on this and looking at all your individual sites with the portfolios, and there is some variability. Sometimes you have an El Nino and it's wet. Sometimes you have an El Nino and it's dry. But one thing I found consistent is that when you have a strong El Nino, you are going to brace for an extremely dry winter. That's something I've seen very consistently in the data. So that's kind of like something that land managers can prepare for when they know a strong El Nino is on the way. And then for the La Nina conditions, we see some opposite conditions. So during the wet season, we see wetter conditions, and during the dry season, we see drier conditions. And again, these are on averages. You can kind of have wet and dry patterns for the La Nina, but again, average, we do see wetter winters during the La Nina. And that's where we're at now. So if you notice a little wet rainfall recently, this winter, you got to get out of here right now, dude. Sorry. And then how is climate changing in Hawaii. Okay, it's been lots of evidence on this recently. We have temperature trends that have been increasing. There's a lot, several papers that have been published on this recently. This is one that comes from the National Climate Assessment, which Maddie mentioned. And you know, you don't need to really get under the lens or even add a regression line here to see what's going on. You see that you know, this is an anomaly, so the red is positive and the blue is negative, and you see we've had a lot of increases in temperature, especially over the last couple decades. And it's very similar to the global patterns, except that even at higher elevations, we find that we're warming even a little faster than the global average. Another key observation is a decrease in stream flow and base flow. So I don't know if this quite gets at what Chris was asking about in terms of water balance, but there is evidence showing that you know, there's less water making it into the streams, and which you know, affects lots of different ecological processes. In terms of rainfall trends, looking at the bigger picture, there's been some evidence of this kind of 500-year drying trend. So that kind of eclipses anthropogenic variability. This is over the last 106 years, looking at this kind of larger scale decrease in rainfall. But really, I think what land managers are most interested in is what's happening you know, in recent years. And Abby Fraser, who's, you know, on this call, has done a lot of work on looking at rainfall trends, and she put out these trend maps for 1920 to 2012 and 1983 to 2012, and they were really kind of a dark you know, outlook, because a lot of the trends were showing these really significant changes in fall. But I've been looking at a lot of this data recently, and I realized that, you know, 2012 is extremely dry. It's the middle of extremely dry period. Now, this is a rainfall time series for Hawai'i Volcanoes National Park. I see this really in all the time series, and I mean, Abby's done a lot of work in looking at these trends, and her conclusion is that it really depends on the year that you start and the year that you end your trend in. So you really can get anything you want depending on where you're at when you start time series and when you end it. But I think the bigger question is now, when I look at the longer term trends, is I don't see a ton of long term changes. But when you look at these shorter ones, you kind of see that, wow, there's been some really significant drying going on. And especially in the period here at Havo between 2009 and 2014. At some of the other sites I look back, it goes back to 2006 and up to 2015. So they, you know, even though we don't see it when we plot a 100-year rainfall time series, we don't say, oh, well, rainfall hasn't changed much. Looking at it in a linear way is really not a good idea. Sometimes you have to really look at, you know, well, what did this dry period do to my ecosystem? How did my ecosystem change as a result of this really dry period that we occurred? And a lot of the drought and you know, metrics I've been looking at show that, you know, there's been these dry periods have existed in almost all of the individual places I've looked at. The 100-year analysis doesn't really give us much, but you know, in 102 or 103 years, if we go through a dry period, it could change the trends again. So it's just a word of caution to be careful of these long-term trends. Even if you don't see a drying over this century scale, it doesn't mean, you know, the rainfall is not changing or that ecosystems are not being impacted. Some of the work that Abby has done is looking at these droughts across the state, and some of the things she's found that per decade since 1920, the frequency of droughts has increased, the duration of droughts, how long they've lasted for, and the severity of droughts, how intense they've been, and average intensity, the peak intensity, and the overall severity, what they've caused. So we see this evidence across the state. But again, when we distill this down to these individual areas, and I'm pulling this from portfolios that I made a bunch of people on this call, we see that you know, even without really any statistical analysis, we can kind of see that this later part of the record, especially in some of these areas, are showing these really long droughts, really long periods. The highest intensity in all four of these plots we're seeing are occurring over the last couple decades, and we're seeing that the number of droughts for all of these places. You can kind of just distill by looking at these graphs that they're increasing. So there is some evidence that droughts are increasing, and I'm seeing that really on this small scale. In terms of future projections, one of the projections is that these ENSO extremes, so these El Nino extremes, these strong El Nino events or these strong La Nina events are going to change. One event for every 27.6 years here, as opposed to one big for every 15.8 years. So some of the recent analysis saying that El Ninos, as a result of climate change, maybe the frequency doesn't change. It still kind of operates in this 3 to 7 year time period, but the intensity of these events are what change. And again, for the strong El Nino in Hawaii, that has significant impacts. In terms of temperature, temperature is going to increase. There's really no dispute about that. We see it globally. We see it here on a local level with the observations, but with the projections as well. With rainfall, there's a little more variability, but for temperature, the word on the street is it's getting warmer. It depends on what path humanity takes. If we're aggressively mitigating the carbon in the atmosphere and reducing the forcing that goes on, we can control that temperature increase. But if we just kind of keep things going the way they're going, then we expect an increase. And then how much of an increase depends on what models you want to look at. But really, there is some consistency in Hawaii between the models, all saying warmer, but the degree of which it does vary by model. But none of them are really good scenarios, because even two degrees of change is really significant to ecosystems. And both models that are available for Hawaii, or all three now, are saying more than 2 degrees. So here's the extreme projection, and this is for Hawaii Volcanoes National Park. I happen to be working on some fact sheets, so I have this figure here, and notice at the high elevation, you're looking at an 8.6 degree Fahrenheit increase, and that's just incredible in terms of changing the sea's composition. And again, we're at high elevations above the trade wind inversion, but even at these low elevations, 7.4 degrees and 6.1 degrees, and then again, this would be detrimental to the ecosystems. And then looking at some of the other places that I pulled out of the portfolio, maybe not as extreme as this high elevation on Mauna Loa, but again, 6.5, 5.5, and 5.6. And this is for the extreme. We do nothing about mitigating carbon in the atmosphere. And this is from one of the statistical downscaling approach that we use. So again, I'm showing you the worst case scenario as far as what we have available, but even the case isn't so great. In terms of rainfall, the general idea that the leeward areas are going to get drier and the windward areas are going to get slightly wetter. But again, this doesn't play out the same. This is a real general approach. And for your individual land areas, you're going to want to look under that lens and not come into that with that assumption, because it could mean different for everywhere. So looking at some of the, again, looking at Hawaii volcanoes, this is again the extreme projection. We see, basically decreases between 50%, 34%, and 31% across this geography. And then looking at some of these individual units for folks that I put these portfolios together, we see, again, pretty much consistent decreases looking at this extreme approach. Most of the places I looked at for the folks on this call and the portfolios, we saw decreases in the future. There's really not much that's saying it's going to get wetter. Almost everything says drier. But again, looking at this map, you see on the Hamakua coast that you do see some wetter projections. So again, it depends on really your own study area. And then in terms of drought, the drought probability looks like it's going to increase, and we've seen evidence in the past, and we expect that to continue on in the future with more droughts, longer droughts, more intense droughts moving forward. Now, the impacts in Hawaii, again, I've covered this already, and there's really so many, and I want to put this out there. If you're looking at an ecosystem and you want to figure out what those impacts are, I'm happy to help you distill that and figure out what information you need to help support your management goals. And it might not be covered in something just like fire or increased temperature, but really I'm happy to look in the literature and see if we can flush some of this stuff out. But in terms of heat, especially with the El Nino events, we've seen an increase in the number of record days in recent time. We've had, during the strong El Nino in 2015, 2016, and this is translated into a lot of impacts on folks, the emergency systems, schools, and again, lots of individual records have been broken in the recent years. The impacts of El Nino combined with this whole increase in temperature. This has had an impact on native forest birds. One reason is that as the lifting condensation level gets a little higher, as temperatures warm, mosquitoes are able to move into the forest bird habitats and bring avian disease with them. Habitats are also shrinking as a result of this warming, and this is having a huge impacts on bird habitat and population. So this is the current population for bird habitat. This is showing with 2 degrees of warming how much that shrinks. So an 85% reduction in forest area just because of rising temperatures. And then that has an impact on birds, expecting up to 50% loss in birds just because of the disease and because of the lost habitat in the future. There's a lot of information on there if you're interested in birds and protect birds. There's a lot of information out there on supporting these findings. Another thing I want to point out is the reduction in the fog zone on the high elevations. So I mentioned the lifting condensation level where clouds form. Well, under climate change, that could get higher. And then the inversion, the base height could actually get lower. There is some evidence that's out there that the base height has been more frequent in recent years in the last 2 decades, but it could also go lower on the mountain. And that would effectively reduce the fog zone. And again, not only reduce habitat for species up there, but it also, potentially reduce water inputs. You may not have the same amount of orographic rain as a result of that. Uncertainty to that, but it could happen. And then we've already seen vegetation responses to long-term drying, so a browning going on. This is looking at 2011-12 data again. So even though the 100-year rainfall, we might not see a trend, these drying periods and these decreases in rainfall have these huge impacts on forested ecosystems. Because if there is a considerable drying or a browning effect, you could make the way for invasive species to come in that are more drought tolerant, and they could overtake native species. Even if rainfall picked back up, it could open up it could be a disturbance event, drought. It also makes way for things like fire when you have this drying, and then again, invasive species can find their entry point after these long periods of drought. So drought impacts. I don't know if we have any folks working with the ranching sector, but we see these huge losses in revenues as a result of drought. We also see these impacts beyond the ecological, but the economic effects of it. We know that in Hawai'i Volcanoes Park and Haleakala, the changes that their experiences. People are impacted by drought in a lot of different ways, not just people, but the ecosystems as well. And then wildfire is certainly another impact on climate change. The warmer temperatures, lower relative humidity, and sustained droughts are all conducive to more wildfire. And we have seen in some time increases in wildfire occurrence. Again, you don't need a microscope here to kind of look at this time series from 1910 to 2006 and see that there's been your biggest fires have happened later in the century. And again, most fires are started by humans. The factor is that if the conditions are ripe, the fires are more likely to occur. So if you have invasive species dominating your area like fountain grass, and you have drought conditions, then with a strong El Nino, warm temperatures and no rainfall, you're basically ripe for a fire. Okay, and again, this is a map of all the fires that have occurred between 2002 and 2011. And let me skip to this part here. So I'm gonna try to wrap things up. That's what I'll talk about data and information. So I mentioned the rainfall atlas. We also have these other atlases out here that can give you interactive maps on different climate variables. Coming in the spring, where there'll be the launch of the Hawaii Climate Data Portal. And this is going to have daily and monthly rainfall maps, daily and monthly temperature maps, real-time fire risk, a catalog of climate references that you'll be able to tap into to support your management activities, and potentially some future climate projections there as well. So this is an effort going on with the Ekivi project, NSF grant, and the Water Resource Research Center. And also what's happening is Abby's part of a NSF proposal to get 100 climate stations. She's working with Tom Giambaluca on that and some other professors at UH. A network of 100 more climate stations built around the state, and this will all feed into this real-time system, and we'll be able to produce these gridded products. And like I was mentioning to Chris earlier, once we start having these gridded products and all of these different variables, we'll be able to do things like water balance for the entire state and really create this whole information revolution for Hawaii, and being able to answer a lot of questions on how things are changing and what are real-time conditions. So I hopefully by the end of the class, I'll have a website or something to show you guys to show you how to get this data and how to get yourself acquainted with the portal. Some other drought information. There's the Pacific Fire Exchange, USDA Drought Monitor, and we have our Pacific Drought Knowledge Exchange, which is a website will be coming soon. And a lot of you know that already and have been engaged in some conversation there about that. And then lastly, I wanted about the CCVD portfolio. Everybody has one that's on this call. If you don't have one of these portfolios, email me after this talk. I was able to generate about 3 or 4 of them for folks over the course of the last week. And these portfolios contain a ton of information and climate specific to your land area. We have version 2 released in the spring here, or maybe in the fall, depending on when data comes available. That will also include monthly fire risk, 31-year temperature trend maps, trends based on these maps that are being developed, and then another year of rainfall. So we'll see what the 100-year of drought and rainfall looks like with that extra year of data, 2020, when that comes available. So yeah, if you're interested in receiving one, these are some of the things that I've made for already, but I'm happy to make more. And even if you have a smaller area within your unit, we look at that. It's an automated system, and I've spent a lot of time on it, and I'm happy to push start and get you one of these. So just shoot me an email and we can talk after class. Okay, so I want to wrap up for questions. I've been through a lot there, and I appreciate everyone's attention, and hopefully kept you awake, and hopefully you learned something. With that, I'll say mahalo.
Thanks so much, Ryan. That was an awesome presentation. Does anyone have questions on any of the information Ryan presented? Looks like Zachary, you have your hand up.
Yeah, so something I was thinking about during this presentation, and this might be covered in the portfolio as well, but when we're planning our like, I guess when we're creating our adaptation plan, is there, like, should we pick a certain projection that we should go with? Like, should we plan for the worst case scenario, or should we plan for, I guess, like, like a middle case scenario? Or is like, I guess, like, is there something we should all pick or like go with to plan for our adaptation stuff?
Well, I think it would be a really narrow approach to pick something that you think is going to happen. We don't know any of this is going to happen, but we have certain trajectories we're on and stuff. So I think that in terms of adaptation, you should probably plan for a range of possibilities. And I don't know if Courtney has anything more to add to that. I mean, really, we're dealing with very sophisticated models that might tell us the future or might not, so the effort that goes into this stuff, there's still a lot of uncertainty in terms of rainfall anyway. In terms of temperature, I would say in my gut is to plan, based on what I know going on globally in efforts to mitigate carbon in the atmosphere, I would say that it's probably better to plan for the warmer scenarios. I mean, some of them are pretty high, but I mean, at least I wouldn't expect it to get cooler.
Yeah, I agree. When we think about adaptation later on in the course, we'll be thinking about a spectrum of adaptation options to really think about that uncertainty and the spectrum of climate projections that we have to deal with. But it all comes down to, I think, what you value about the lands where you are and how much risk you're willing to tolerate. And so if you want to think about that worst case scenario and plan for that because it's something that's really valuable and important to you, then that's a good way to go. If you aren't concerned with that amount of risk for something that you're managing within your system, then maybe you think about it somewhere within the middle. But it's up to us as the managers and the experts on the ground to figure out what makes the most sense for the areas where you're working.
I had a question about the vulnerability of ecosystems. And so I'm just thinking of a lot of pasture land that used to be forest that folks want to return to forest, and the vulnerability of those ecosystems to change may be relatively low as grasslands. The vulnerability of the forest, once restored, may be high or moderate. So I assume we should be projecting out the vulnerability of the desired ecosystem state that we want.
Brian, do you have additional feedback on that?
Well, yeah, there was a similar question earlier about that. I think that you have to, plan. I mean, like I've had some talks with Sierra about this in terms of, planting when restoring areas. Do you want to plant a species, that's thriving in an area when it's going to get warmer, or do you want to plant a species that is more tolerant to a warmer temperature, knowing what's going to happen in the future? So I think that you have to, definitely think forward in terms of that and plan for the ecosystem that will be there, not the one that's there now.
Other questions for Ryan? Or in general?
This is Heather. I'll chime in with a comment again, if that's okay. That was great. It was really nice to see the compilation of materials, and then I haven't seen any of the packets yet because I don't have a specific project, but one thing I was thinking about as you were talking about that is just how much work likely went into getting that information to just one specific area, right? So like when the manager or a manager is working on their area, like how are they accessing all of that you put together? I mean, was that even a possibility, or, or are we looking at a potential of being able to provide that type of information so somebody could do that? Or like trying to manage an area would require a research scientist putting a portfolio together to help people do their adaptation planning. And, again, I don't know what's in the packets exactly, but it's good to see that compilation of material because I think it's sometimes overwhelming what is out there and where to find it and what it means.
It would be absolutely overwhelming for anybody to approach it, try to compile this information on their own. I mean, most of the stuff isn't even available publicly, or if it is, it's in a put together way where it requires some skills to be able to even open it up and get the information. So, but the beauty of it now is that it's all automated at this point. Everything I'm doing is automated. So it all pulls from all these different products. So moving forward, so my plan is, and with the scaling up we have with the Hawaii Drought Knowledge Exchange, is to continue building these portfolios, and as they update, just to send them out to everybody that has one with the updated version, and to, you know, include more information in them. And what really is, like, you can go on one of these rainfall outlets and click on a point and get your rainfall, but you know, you can't, you know, that's for one point. If you're looking at a whole geography, you know, you need to have some GIS skills. And then again, the things like the rainfall data and the time series stuff, and that's just not available until that portal launches. But you know, I have my hand in a lot of other things around the state that like give me access to data and stuff. So really, it's a pleasure to be able to share it with folks. But yeah, for someone to do this on their own, it would just be overwhelming. I mean, it's taken me a year to get to this point of being able to have this, you know, automated. And yeah, moving forward, that's why I have draft on all the portfolios, is because I just want it better, and I want to make sure that you know, there's really no final version as data keeps coming in. So I'll probably always just keep it as a draft form until I move on, which I don't know when that will be, when the money runs out. Yeah.
Well, that's a telling, like, you know, statement, right? Like, just to get to the information takes someone who's been practicing and has secret codes to the data or something for
Well,
some of it.
I mean, that's the whole premise of the project, is the drought knowledge exchange, is to be able to, you know, have this collaborative process with scientists and land managers, and be able to exchange information that otherwise really wouldn't be, you know, easy to get. And you know, I'm putting this out there. My role in this course is a supportive role. So anybody who needs any information about anything to do with the climate that's not in the portfolio, or if you need any information in terms of scientific literature, I mean, this is what I do. So I will go under the hood and look down and get that information for you, because it's going to enrich my experience and my knowledge, and I'm going to be helping you. And I'm basically being funded to facilitate this exchange between you guys and science, and I'm happy to do that. So if you have any questions or any data needs, please don't hesitate to reach out.
Awesome. Thank you so much, Ryan. We're really grateful to have you here as a resource for this course as well. So yeah, that is it for today. And so if you do have additional questions or need additional resources, you have Ryan's email, and feel free to contact Maddie or I or any of the other facilitators as well, and we can get you connected to those different references or resources. Our next meeting will be next week on Tuesday, February 9th. And so we'll be discussing again those climate change impacts that you're starting to think about for your projects, and then start talking about the challenges and opportunities that those create for management next week. So mahalo, everyone, and we will see you all next Tuesday.